Okay, so in week 2, part 1, we looked at sequences and slices. We also talked about the idea of object ID. And along the way there, we introduced the is equal to operation, which is the double equal to, for comparing values on the left and the right. We also introduced the is identity test that checks whether two variables in this case refer to the same object or not. So we've seen a couple of examples of operators that produce these Boolean values true and false. Here in part 2, we're going to introduce the if-else decision, which enables us to execute code conditionally depending on whether something is true or false. We're also going to introduce the other equality, relational, membership, and logical operators, and or a not, that we use to make decisions using if-else. So off we go. All right, so in Python 3, here is the general form of an if decision. It starts out with the keyword if, then you have some Boolean expression that tests whether some condition is true or false. Following that, you have a required colon, just like we had a required colon at the end of our for loop syntax. Now, if the Boolean expression evaluates to true, then the statements in the body of the if are executed. Notice that these things are indented. The statements in the body of the if have to be indented in the same way that they're indented when we wrote a for loop. And we may have multiple statements within the body of the if. If so, they have to be indented by exactly the same amount as each other. And Python will get very upset with you if your indentation is not precisely the same. So let's take a look at an example. I'm going to set a variable a to refer to 12 and a variable b to refer to 12. And then I will use an if decision if a is equal to b. Whoops. Colon. All right. So if a is equal to b, then we're going to do something. And notice that the shell automatically gives me an indentation. In this case, what I'm going to do, if the value of a, all right, if I'm being really picky here, I would say that the value that a refers to is the same as the value that b refers to. We usually would just ask whether a is equal to b, that is, those values. If those values are equal, then we're going to double the value of b. Remember that this assignment operator means the same thing as if we said a gets b times 2. Okay? And that's all we're going to do in our if. So I'm going to hit a blank line now, which will tell Python, the Python shell, that I'm done typing in my if decision. What will we expect is going to happen? Well, a refers to 12, b refers to 12. Certainly those values are equal. So we would expect, because that test produces true, that test is true, we would expect that b's value is going to be doubled. And it is. So b now has the value 24, or technically b refers to the value 24. A still refers to the value 12. I can create another variable inside the if decision if I like. So let's set a to 12. We haven't actually changed. I mean, a was referring to 12, and now a is referring to 12, so we could have left that out. But now let's set b to refer to 12 again. And this time let's have a body of our if. Okay, my fingers want to hit that double quote. There we go. Okay, so if a is equal to b, which it is, what we're going to do now, just to illustrate the idea of multiple statements within the if, is set a variable b, set a variable c to refer to a -4, and then modify the variable b to the value of a plus c. Now, since c is a -4, of course, this is equivalent to saying the value of a minus 4, and that should be an 8. So the upshot of this is that b's value, when we're done, should be 8. A is still 12. Now, I haven't said anything about global variables versus local variables yet. If you're familiar with other programming languages, those terms may be familiar to you. It turns out that A and B here are what are called global variables or top-level variables. They're going to be visible throughout all of the code that I'm writing in my shell here. And C, when I define C to refer to this value -4, it also, it turns out, is a global variable. And so that variable C continues to exist even after this if statement is over and contains the value -4. If you haven't done much programming, this probably just causes you to shrug and say, who cares? If you have done programming in other languages, this may somewhat surprise you that a variable that I create within this if continues to exist after the if is over. In any case, we've illustrated the idea here of having an if decision controlling 2 lines of code. Okay, now here's an okay, I keep hitting that edge. There we go. Here's an example where we're showing you how picky Python is about its indentation. I'm going to say if a is equal to b. I'm going to try to say if a is equal to b, then c gets -4, b gets a plus c. Now, it's obvious what I'm trying to do here, right? If a is equal to b, I want to set c to -4, and then I want to set b to the value of a plus c. But Python is very, very picky about indentation, and it yells at me because I accidentally typed a space before I typed the variable name b. So this is either this is either a feature or a nuisance, depending on your point of view. But be prepared to get yelled at if you don't have exactly the same amount of indentation for statements that you have indented in an if, or indented in a for, or indented in various other constructs like functions that we'll talk about later. In fact, you can't even get away with accidentally hitting an equal sign, a space. You can't even get away with accidentally typing a space at the beginning of a single line. Here I'm trying to say D gets 12, but I accidentally typed a space before I hit D, and again, Python will yell at me about this. So, this is a controversial feature at some level about the Python language. One good thing about requiring consistent indentation is that pretty much every programmer's Python code looks like every other programmer's Python code. You don't get into stylistic, philosophical, religious debates about whether you should or should not have curly braces around things, which is a common way of bounding statements in other languages. And of course, you don't have these curly braces that you have in languages like C and C++ and Java and C#. You just don't have those curly braces to keep track of. The downside of this required indentation scheme in Python is that you're forced to do line continuations for long statements, which is kind of awful. And if you had an if statement, let's say, that didn't have just two statements within the body or the block, but instead had something like 15 statements in the block, then that might not all fit in a single screen. So you might not be able to see the test that you're performing and all of the statements being controlled by that test all on the screen all at the same time. Okay, so that is another possible downside. Now, in my early days, back in the previous century, I cared deeply about code formatting issues and was involved in vigorous, sometimes not even very pleasant, debates with my fellow programmers about how you should properly format your code. In my case, that was C code. And we had all kinds of arguments about positioning of parentheses and curly braces and how wide your indentation should be and whether your function names should have uppercase letters in them or not, and on and on and on. It's useful to have opinions about style. It's very important that you develop a consistent style so that your if statements all look the same as each other. Let me show you a particular example so that if you'll notice that I've been saying things like A gets 12, and I've typed spaces around that equal sign, and I haven't even mentioned it. That is my style. That's a very common style. You can, of course, say A gets 12. I say, of course, maybe it wasn't obvious to you that you can do that, but you can say A gets 12 with no spaces in it. The main thing is be consistent. Don't write code that looks like C gets 15 with spaces, followed by D gets 22 with no space, followed by E space gets 123, followed by E, F gets space, 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 1234. All of those are legal assignments. All of these are legal assignments. But it looks to someone reading your code like you're a very sloppy programmer. All right, so you do want to adopt a consistent style. And although it's useful to debate with people about style, it's not useful getting angry about it. And if you find yourself working with a group that has adopted a particular style, don't waste your time trying to persuade them to use a different style. Just shrug and do what everybody else is doing and live your life. Okay, so that's everything I'm going to say about code style in this course. Have a good, consistent style and alter your style to conform to the group that you're working with when you need to. Well, so an if may also have an else part. You can think of else as meaning otherwise. So the idea here is if some Boolean expression is true, like A is equal to B, if that's true, then we're going to perform the block of statements, one or more statements, that are indented underneath the if. But optionally, we can have an else part, which also, by the way, has to end with a colon. And so if the Boolean expression is false, we will drop down and perform the statements contained within the body of the else part instead of the if part. Here's an example of this idea. I'm saying X gets 12.3. In these examples, or in this example, I'm using a less than operation rather than an is equal to operation. I'm saying if X is less than 12, then we're going to display, using the print function, X is less than 12. Now, the else must be indented to exactly the same level as the if. This is Python's indentation rule. And idle, on the other hand, by default, has given me the same level of indentation as the print function call. So if I typed my else here, that would actually be an error, and Python would yell at me. Let's go ahead and illustrate that. I'll just hit the Enter key. And you see I get an error message. Now, invalid syntax is not a very detailed message. So if you're a relatively new programmer, that tells you did something wrong, but it doesn't tell you specifically what. All right, so I'm telling you specifically what. I'm telling you that it means that your indentation is incorrect. So we're going to say if x is less than 12, print x is less than 12. I need now to hit the backspace to make sure that my else is at the same level of indentation as the if. And here again, this is going to look odd because when I hit the backspace, in idle, my cursor goes all the way back to the left edge. So now it's going to appear still that my else is not at the same level as my if. But it is at the same level. And the reason it's at the same level is because these characters here, the 3 greater than symbols in the space, those are the Python shell's prompt. Those are not part of the input code that you typed. So from the shell's point of view, you typed if as the very first 2 characters on your input line. And now we're typing else as the very first characters on the 3rd input line. So I've got an input line here consisting of if space x space less than space 12 colon. Then I've got an input line here containing my print function call. And now my else is at the same level. It's at the left edge on my next input line, the same level as if. And now I can type what I want to have happen in the else part. That is, if x less than 12 turns out to be false, which it will be, by the way, because remember that x is 12.3, and so x less than 12 will be false. We're going to say print x is not less than 12. All right. Now, the shell, once again, has indented to the same level as the print in case I want to continue typing more statements. But actually, this is all I want to do in this illustration of the if-else. So I will enter a blank line now. Just press the Enter key. And the code ran. So x was set to 12.3, and 12.3 is not less than 12, so that expression is false, and I can confirm by just doing that part. X less than 12 is false. Consequently, we skip the statements contained in the body of the if part and instead drop down and do the statements in the body of the else part. And here there's only one statement, which is to print that x, whatever x's value is not less than 12. And here we see that x comes out as 12.3. This comma here causes a space to be displayed. And then we have this string, is not less than 12. So there is why we got the output that we got using the if-else. I always, except this time, I essentially always forget to put my colon at the end of the else. And I don't know why, because I've been doing this for some time, but I never have trouble including my colon at the end of my if line or at the end of my for line in a for loop, but for some reason I have a blind spot about remembering to put my colon at the end of the if, at the end of the else, and so I often get yelled at for that, but in this case I actually did it correctly. Now, in addition to the if, which has to start the if decision, and the optional else, which can be at the end of the if, you're also allowed to have 0 or more elif parts, which is simply abbreviation for else if, in between the required if and the optional else. Okay, so here is a full-blown if, elif, 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 else decision structure. And it all has to be indented at the same consistent level. So here on slide 11, we're illustrating this idea. Now we're going to say x gets 12.0. Then we're going to ask if x is less than 12 or x is greater than or equal to 13. All right, so that's our first test. We've got a couple of new things going on here. We have this logical operator OR, which means what it sounds like it should mean. We're asking whether this thing on the left is true or this thing on the right is true. The other new thing is that we're using a greater than or equal operator here, which has the obvious meaning. We write it as a greater than symbol followed by an equal sign, whereas in math you would just have a greater than sign with an extra dash, an extra slash underneath for the equal. So if x is less than 12 or x is greater than or equal to 13, we're going to print that x is greater than or equal to 12 and less than 13. Print x is greater than or equal to 12 and less than 13. Now, interestingly, and I guess I had done this on purpose and then forgot, this statement here is false, right? I mean, it's an untrue claim. If x is less than 12 or x is greater than or equal to 13, then it's certainly not the case that x is greater than or equal to 12 and x is less than 13. But fortunately for us, since this condition is false, this print statement is not going to be executed. So in this case, we will not confuse the user of our code by displaying an erroneous message. All right, I hit the enter key. Notice that I'm indented at the same level as print, which is not what I want, so I'm going to press backspace. My elif now is testing whether x is 12. Let's think about this. X is referring to 12.0. Is 12.0 the same object as 12? Well, it can't be. Numerically, these two values are equal to each other. So if I use the double equal to symbol, the is equal to test, equal, equal, this is asking whether x is the same object as 12. And that's not true. X is referring to the object 12.0. 12.0 is a float, whereas 12 is an int. And so I haven't shown you this specific example, but x is not the same thing as 12. X is referring to a different object from the integer 12. So here we'll say print x has a different ID from 12. Now here again, amusingly, this is an erroneous statement, but we're not going to print that one anyway, so it doesn't matter. And finally we get down, and here I'm going to have to press my backspace again. Finally we get down to the else. Print the value of x is x. Okay, so I'm done. Ordinarily, you would not type in a 6-line code example in the shell. You can do that for practicing with things and for demonstrating things or for testing things. But now that we're at the business of these if, elif, else decisions, we're going to quickly switch away from using the shell anymore to writing things in program files where it's easier to correct bugs. Now, I've been very carefully typing this out correctly. I haven't made any typing mistakes, so this will work, but it's really tough to type 6 lines of code interactively in your shell and not make any typing mistakes. In fact, I noticed here that I even remembered, I'm very impressed with myself, I even remembered to put the colon after the else. Okay, so we'll hit the enter key here, and there, we get told the value of x is 12.0. Okay, 12.0. Is x less than 12? That's false. Or is x greater than or equal to 13? That's false. So false or false is all false. That means we skip to the elif. Here we're asking if x is the same object as the integer 12, and that's not true, so that's also false, which is going to drop us down to the else, and this gets executed, then this print statement gets executed saying the value of x is 12.0. Now, you can have as many of these elifs as you want, including none. In all of this stuff, what's required is you have to have an if in order to make a decision. Optionally, you may or may not have elifs, as many as you want. And optionally, you may have exactly one else. And if you have an else, it has to be at the very bottom of that if, elif, else structure. Alrighty. So here is, on slide 12, the complete collection of equality and inequality operators. Notice that the inequality, the not equal to operator, is the exclamation mark equals. This is the same notation as is used in C, C++, and Java. It's different from Pascal and some other languages. Here are the relational operators, which are fairly self-explanatory: less than or equal, greater than or equal. And here are these identity operators. Is, which means that the thing on the left is the same object as the thing on the right. And is not, which means the thing on the left is not the same object as the thing on the right. So if I ask whether 12 is 12.0, this is false. If I ask whether 12 is not 12.0, that is true. Then the logical operators are these words, not, and, or. This table is shown in precedence order from high precedence to low precedence. All of the equality, relational, and identity operators have the same precedence as each other. And those all have a higher precedence as that compared with not, which in turn has higher precedence than and, which in turn has higher precedence than or. So of all of these operators, or has the lowest precedence. Just as with arithmetic, if we want to alter the precedence, we can use parentheses to group around things. Okay. Now, I've mentioned this little tidbit before. I pronounce the double equal sign operator as the is equal to operator to strongly differentiate that when I'm talking about code from the single equal sign, which I pronounce as the gets operator. If you call equal is equal to and call equals gets, you won't confuse people if you're talking to them face to face or if you're talking to them on the phone. They may ask you, what do you mean by gets? And then you can just say, well, I mean assignment. But it's a lot better than saying things like X gets. Now, I've got myself so well trained, I can't even say it wrong. If you say X equals 12, X equals 12, and you say equals for both the assignment and the equality test, that's just going to be confusing to someone trying to understand what you're talking about. So this is why I say X gets 12, X is equal to 12. It makes things much more clear. And as I said, the exclamation mark equal is the is not equal to test. X not equal to 1234 is true. Before I leave this table, let me back up to slide 12. And I'm going to repeat the same evil admonishment that I made about the arithmetic operators. You really do have to know the meaning of all of these operators as well as the precedence of all of these operators. It is simply not optional. So you must basically memorize this table shown here on slide 12. Okay, here on slide 14 are some various illustrations of these operators. If I ask whether 4 is less than 12 and 7 is greater than 2, well, and has lower precedence than the less than test and the greater than test. So this means the same thing as 4 less than 12 in parentheses and 7 greater than 2 in parentheses. 4 less than 12 is true, of course. 7 greater than 2 is also true. True and true is true. In mathematics, you can meaningfully write statements like this, or expressions like this. Actually, let me set I to 8. All right, I gets 8, and then I can ask whether 4 is less than I, which in turn is less than 15. That's true. In many languages, modern languages that are widely used, C, C++, Java, this would actually not evaluate in the way that you would expect. I'll just leave it at that without going into detail. But in Python, this is valid, and it's treated as, all right, so 4 less than I less than 15 is treated as 4 less than I and I less than 15, which in turn is 4 less than I in parentheses and I less than 15 in parentheses. All right, so in C or C++ or Java, you would have to separate out these two tests and put an and in between. And depending on the language, you might be able to use the word and, or you might have to use something else like a Whoops, what's going on? Oh. It won't let me continue typing there. In other languages, the double ampersand is used to mean logical and in many cases. Okay. Now, not only can you use these relational and equality operators with numbers, but you can also use them with strings. All right, here I am setting s gets hello, and I can test whether s is equal to hi or s is equal to hello or s is equal to howdy. And the implied parentheses are around s is equal to hi, s is equal to hello, s is equal to howdy, and the or has lower precedence than these equality tests. Well, is s equal to hi? That's false. Is s equal to hello? That's true. Is s equal to howdy? That's false. However, because we are ORing these values together, false or true or false is true, because one of these expressions in here was true. Consequently, the whole thing is true. In fact, for efficiency, when Python sees a sequence of these logical operators, and or, Python does what's called short-circuit evaluation of these operators. And what Python does is to first test whether s is equal to hi. Now, if that's true, then true or anything is true, and there's no reason for Python to do any further checking. So if s is equal to hi is true, that's all we do. We short circuit any further tests, we say that that whole expression is true, and we move along. In this particular example, s is equal to hi is false, so we do go on to evaluate whether s is equal to hello. At this point, s is equal to hello, that is true. So since that thing is true, false or true is true, the whole thing is true, so we don't bother comparing s with howdy. All right, so often when you have a sequence of ors, or if you have a sequence of ands, you organize these things in such a way that you can take advantage of this short-circuit evaluation. That is, if you anticipate that something is likely to be true, then you can test that thing first, or test another thing, or test another thing, or test another thing, or test another thing. But if that first thing is true, you're done. You don't have to evaluate any of those ors. Okay, you short-circuit, you've discovered that the whole chain of the first thing, or the second thing, or the third thing, or the fourth thing, if the first thing is true, then all of it's true, and you don't need to evaluate those other ones. Another thing that's nice about strings is that you can compare strings in relational order. That is, for less than or equal, greater than or equal. Now, lexicographic sort of means alphabetic. However, uppercase letters and lowercase letters are treated differently. So, if I test whether hi, all right, I hit the enter key, I didn't mean to. If I test whether hi is less than hello, this turns out to be false, because although the h's match, the I and the E do not match, and the I, lexicographically, or in dictionary order, comes after the E. So hi is actually greater than hello, and I get a false from this comparison. If I ask whether hello is less than help, well, in this case, the first three characters, HEL, match on both sides. And then this fourth character, this little l, is alphabetically earlier or lexicographically earlier than the little p. So this test is true. Uppercase letters mix things up a little bit. If I ask whether big is greater than small, the capital B comes ahead of all lowercase letters. So this is going to be false. Okay, that is, let me use another example. Hello with a capital H, hello with a lowercase h, these are obviously not equal. In fact, hello with a capital H comes earlier in the machine's character set than hello with a little h. It turns out that the character set that's relevant here is what's called the ASCII character set. And in the ASCII character set, all of the capital letters come earlier than all of the lowercase letters. And so this is going to be true. Let me do another example involving a list. I think this is probably a good idea. So let's say ABC, DEF. Notice I'm just using different so-called delimiters, single quotes, double quotes. Let me use a triple single quote, triple double quote. All right, so now I've got a list of 5 stirs, and if I sort this list, they'll be sorted in lexicographical order. And what I claim should happen is that capital DEF should be first, followed by capital JOE, and then ABC, Howdy, and WXYZ. And there we are, okay? All right, so that gets us to the conclusion of the if, elif, else decision. And we've also introduced the equality and inequality, relational, identity, and logical operators. All right, so the lab will give you a little bit of practice with that.